Though very common, direct camera flash is known to make subjects look flat and harsh, which is particularly unflattering for portrait photography. For this reason, advanced photographers prefer to use a bounce flash to reflect light off of surfaces around their subject. Effective use of a bounce flash is difficult though. Photographers have to dynamically predict how light will interact with a complex 3D environment and manually adjust their flash to adapt to different scenes. Inspired by the impact of on-camera tools for automatic metering, we propose an automatic solution for controlling the direction of a bounce flash. Our solution is to augment a regular camera with a motor-actuated flash, as well as a fisheye camera and depth sensors for capturing and analyzing potential bounce surfaces. The device constantly evaluates the color and geometry of potential bounce surfaces in a room, as well as their relation to the direction of a subject's gaze, and automatically directs the flash towards good surfaces. Here we see our system used to keep the flash pointed at a particular surface during the capture of a panorama. By tracking a consistent bounce surface, the photographer avoids accidentally firing the flash in bad directions, like the opening on the wall behind him in this room. When we compare to a panorama captured without tracking, we see that our system prevented unwanted reflections and underexposure in parts of the scene. In this last example, we rolled our system down a hallway in front of a walking subject. This scenario would be quite difficult with a normal bounce flash because the photographer would have to constantly evaluate their surroundings and adjust the flash while walking backward and keeping the camera centered on the subject. But with our automatic bounce flash, we need to only focus on keeping the subject centered and not tripping over anything. In a moment, the camera will pass by a poor reflector on the right, and we'll see our system react by pointing the flash towards a white wall on the left. Now we're starting to see a poor reflector on the left, but we're almost past the poor reflector on the right. So in a second, the system will notice this and switch directions again. And in this narrow hallway, the system mostly just has to dodge things like doors and trophy cases on the two opposite walls. But now we're about to pass a stairwell, and suddenly neither wall will make a good reflector. Luckily, our system will notice a bit of white overhang near the ceiling on the left, which is about as much as can be done in this scenario.